All right, we're going to talk about how Earth's plates are on the move constantly. All right, the lithosphere of Earth is cracked. Oh my, no, really, it is cracked. It's broken up into pieces called tectonic plates. Okay, it's kind of like the chocolate coating on a Dairy Queen dipped cone, ice cream cone. You know, when you dip it in there, it's all nice and solid, but then the ice cream starts to melt and the cone and the chocolate starts to crack. It's kind of like that, or kind of like a cracked eggshell. All right. Most of Earth's tectonic plates include some continental crust, which is land, and then some oceanic crust, which is the ocean floor. All right. So see, you can see on this map here, there's continents, and then there's ocean, but some of the plates are part ocean and part continent. See, like the North American plate, the North American land is on this part, but then right down here in the middle of the Atlantic Ocean, that's oceanic crust, but it's still part of the North American plate. Same thing with South American plate here. You see, here's South America, the land, but then here's the ocean. All right, then some plates, like the Pacific plate, they're mostly ocean. Okay, oceanic crust is more dense because it forms under the weight of all the water in the ocean. And continental crust is less dense because it doesn't have the weight of water pushing down on it when it forms. All right, tectonic plates are named for where they are located. All right, North American plate is obviously located where North America is. Pacific plate is located where the Pacific Ocean is. The Eurasian plate is where Eurasia is. Okay. Plates move, really. Okay, remember that the asthenosphere or mantle, it has plasticity. It's a squishy solid that behaves like a thick liquid. Okay, here's an example of a solid with plasticity. All right, some people call this oobleck. You make it with cornstarch. All right, it pours like a liquid, but when you squeeze on it, it acts more like a solid. It's a very strange material. All right. Tectonic plates of Earth float on top of the asthenosphere, so they are floating on top of this material that has plasticity. All right. So how do the plates move? Well, heat from the Earth core, remember the Earth core is very hot, okay? It causes convection currents to move this material with plasticity in the mantle. See these circles right here? This is showing you that heat from the core causes this material to move up. When it gets hot, it rises, and then it cools off, and it sinks. It moves like the wax in a lava lamp. Okay, that's what's going on in the mantle or the asthenosphere. The convection currents in the mantle cause Earth tectonic plates to move very, very slowly. Okay, this is not happening fast. It's not like boiling water. Okay, remember this stuff is very thick. Most of Earth's plates move only about 1 inch per year. So you don't even feel it. Occasionally you feel it with an earthquake, but not very often. Okay, so what kind of plate boundaries do we have? All right, there's 3 types of plate boundaries, and you learned about these in the graham cracker lab. All right, there's convergent boundaries, where the 2 plates are coming together, pushing together like this one. There's divergent boundaries, where the 2 plates are pulling apart like this one. And there's transform boundaries like this one, where the 2 plates are sliding past each other. All right, convergent boundaries. Okay, at a convergent boundary, the plates move towards each other and collide. All right, this is an example of one, and this is an example of one. There's actually 2 types of convergent boundaries, and we're going to talk about those next. All right, the first type of convergent boundary is when 2 continental plates collide. The crust gets pushed up and mountains form. Okay, so when these 2 plates are colliding, or see the arrows show how they're pushing together, when they collide, it just kind of folds up and pushes up like these mountains right here. Okay, and we modeled this with graham crackers. Remember when we first pushed the graham crackers together, they pushed up. That is an example of a continental convergent boundary. All right. The other type of convergent boundary is called a oceanic and continental collision. And when the oceanic plate and the continental plate collide, the oceanic plate subducts under the continental plate. Okay, it means subduction means it gets pushed down. Remember, we had that vocabulary word, subduction. So the oceanic plate gets subducted because it's more dense than the continental plate. So the continental plate kind of floats on top of it. When the oceanic plate gets subducted, it melts and it forms magma, and that magma rises to the surface and forms volcanoes. All right. And when we did the graham cracker lab right here, this is the example of subduction, when this cracker was getting pushed under or subducted under this other cracker. All right. Our next type of plate boundary is called a divergent boundary. Okay. When two tectonic plates separate, it's called divergent. Okay, here's a picture of one. These arrows show the two plates separating, and when they pull apart, magma is able to come up in between them. All right, and this is the picture of the graham cracker lab when we pulled the graham crackers apart. Remember, we could see the pudding in between. That shows you that the mantle is exposed. All right. When the two plates separate at a divergent boundary, magma rises to the surface. Okay, it's basically pulling the earth apart. Magma is going to come up, and then when that magma cools, it forms new crust. All right, so this is where crust is made on Earth. All right, most divergent boundaries occur in the middle of oceans at what is called a mid-ocean ridge. This map of the Earth shows where mid-ocean ridges are. And this is where there's all divergent boundaries, and at these divergent boundaries, the crust is pulling apart and new crust is being formed. All right. There's a couple places on Earth where there's a divergent boundary on land, and when that happens, it's called a rift valley. Okay, the same thing happens. The two plates are pulling apart. When they do, there's a crack in the ground, in the crust, and lava can come up and form new crust. You have volcanoes here. This is a picture of a rift valley in Iceland. Okay, it's an island in the middle of the Atlantic Ocean. You don't see lava all the time. Volcanoes aren't erupting all the time, but there are a lot of volcanoes nearby rift valleys. All right. The third type of boundary is called a transform boundary. Okay, when two tectonic plates slide past each other, it's called transform. Okay, this picture here shows this plate's moving this way, this plate's moving this way. They're sliding past each other, and we did that with the graham crackers. Okay, remember we slid one past the other one. All right. Friction between the two plates at a transform boundary causes earthquakes. All right. These are the most active boundaries. They slide, again, they're still not moving all the time. They slide just a little bit at a time, but they get caught, they get stuck. Friction causes them to get stuck, and the pressure builds up, and then when they finally move, it moves a lot suddenly, and that causes an earthquake. And you can see this picture here shows some earthquake damage. This is a picture of a transform boundary where the two plates are sliding past each other. All right. California is known for a very famous transform boundary called the San Andreas Fault. All right. This map shows you where the San Andreas Fault is in California. Okay. And you see from the arrows right here, this part of it, the part closest to the Pacific Ocean, is moving toward the north. And the North American plate over here is moving kind of toward the south. So this part of California, where LA is, San Diego, and even up here at San Francisco, these are all on the Pacific Ocean plate. It's continental crust, but it's on the edge of the Pacific Ocean plate. And when it slips, they can have earthquakes. Most of them are minor, but sometimes they can have some really major earthquakes. And this is a picture of the San Andreas Fault. You can see where the crack in the ground is, where one plate is moving one way and one plate is moving the other.